Hey everyone, welcome to the video. Today we're going to tackle LeetCode number 2, which funnily enough is named Add Two Numbers. It is a great first medium problem in my opinion. So if you want to add a LeetCode medium feather to your cap, so to speak, I think this is a great problem to tackle. Yeah, let's jump into it. So if we're reading the description here, we see that we're given two non-empty linked lists that represent two non-negative integers. So basically, we're getting two data structures that aren't empty and they represent positive integers. One thing to read here is that they're singly linked lists, not doubly linked lists. If you're a Python developer, I do all my solutions in Python. You maybe haven't dealt with a linked list before. This is kind of a low-level data structure, something that you would see in like C++ or a lot of functional programming languages. Don't worry about it. It's going to be pretty easy to deal with. I mean, you can kind of look at the object definition here, right? There's only two methods, so how hard could it be, right? All right, what else do we know? The digits are stored in reverse order. Okay, that may set off alarm bells. You may be wondering, oh no, not only do I have to work with this new data structure, but I have to reverse it? No, that's not the case. In fact, the fact that they're in reverse order is going to be beneficial for us because we're going to be doing addition, as you might tell from the intro, the name of the problem. And, doing addition actually works best when you start with the smallest number in a number. So like with this example here, 243, 2 is actually the smallest number because it's stored in reverse order. And, you work up to the larger numbers, kind of like you would if you did this by hand. All right, what else are we told? Each node has a single digit. That's kind of obvious, if you just look at these pictures, but it's good they tell us that. And then we have to add the two numbers and return the sum as a linked list. One thing they don't tell you in the problem description, but you can kind of see with the examples, is that not only do you need to return the answer, you need to return it in reverse order, which again is actually beneficial because that's how we're going to sum up these individual elements. More on that in a little bit. Finally here, just some extra information. It says you may assume the two numbers do not contain any leading zero, unless basically that linked list represents the value 0. So if there's a 0 at the start of a linked list, that means that entry, the first or second number, is 0 itself. So you would just be adding 0 to another number. Hopefully not 0, but maybe they're both 0. Okay, that's a lot of words. Let's dig into the data structure and look at what we're dealing with here. Before we jump into the problem properly, we need to cover some prerequisite info. First thing we need to look at is the definition of a linked list, so the object definition here. If you look up information about linked lists online, you may find information about like C++ linked lists, for example, which have things like pointers and memory addresses and things like that. We don't have to deal with that right here. The only methods we have are a value method, which should store an integer, and a next method, which you can say points to the next list node, or none type if we're at the end. There's no guardrails here in these object definitions, so you can put anything you want in value in next, but if you do, you won't get the problem right. This has got to be an integer, and this has got to point to either a list node object or none. I've got a helper function here. Helper, that's a wrong term. This function is to help you, not to help another function. And it's just a way to easily print out the contents of a list node without having to manually iterate through them. Feel free to use this if you want to. It's pretty straightforward. All right, let's play with these for a little bit. So what I've done right here is I've copied in list nodes that come from the very first example. So if you look at the problem here, 243 and 564 are in example 1. They represent the numbers 342 and 465. And I've got them in list node format down here. So again, you can see how the generators are used. We've got a list node object, which has a value of 2, and its next value is another list node object with a value of 4. And finally, it has a next value of list node 3 with no second argument, meaning that the next is going to be none. And the way you can kind of think of this in your head if you want, it's kind of like with arrows. I think that helps visually. So 2 is pointing to 4, which is going to point to 3, which is going to point to the end, kind of the stop sign of the whole thing, which is the type none. And so the way that you can work through these, let me make sure this is in memory, it is, you can get the value of L1 using that method, or you can go ahead and get the next value by calling next on it and get you 4. And you can continue this all the way until you get to the end. So if you call next, I think 3 times here, you should get an error because it's type none. So there's no value for type none. And then, of course, you might as well do them all here. If you call next twice, then you get 3. Okay, don't be confused by the syntax. They're real easy to work with. And we have to work with them because notice that the result here is a singly linked list stored in reverse order. So we can't get away from this data structure. We can't just parse it. We also have to generate it. There's also a function called divmod we need to use. So in regular integer division, if we divide, say, 18 by 10, we get 1.8. That's the correct answer. However, in this problem, since we're returning whole integers and we're doing addition, we need this divmod function, which lets us do something like this. So if we take 18 and call divmod with 10 as the argument, it takes 18 and divides it by 10, but it returns the remainder, the small value that you'd get if you did division by longhand. And if we call this, we get 1 and 8. And just so you know what this means, it means that 10 goes into 18 one time with 8 as a remainder. Okay, one final concept here. You're going to see something in the solution where we have a list node that has 2 variables assigned to it. And it really kind of isn't obvious if you don't know why that's happening at first. So I really want to make it very, very clear here what's going on. You're going to see something like root is equal to answer is equal to list node with no argument. And the reason we're doing this is because of the nature of singly linked lists that and because of the way that we have to work through them. So we can't call an index or a length operation on these linked lists. So the only way for us to move through them is to do the code that kind of looks like this. So we're going to say, while we have our first list, we're going to create some value that we may store. So here, a value, I'm going to call it v1 to be kind of similar with what you're going to see in a little bit, is going to be equal to l1.value. And then we're going to take that value and we're going to store it. So answer.next is going to be equal to list node of v1. So we're creating a list node that is stored in the next position of answer that has value 1. So the first time through this loop, that would be a 2. And then to keep the loop going, we're going to have to update L1 equal to L1.next. And before we do that, so we can also keep putting things in the right position and not just overriding them every time, answer is going to have to be equal to answer.next. And then if I get to the bottom here, after we do this, if I want to call the recursive print function on answer, I'm going to get the value 3. Why am I getting 3? Because when this loop exits, we're on the final position. Remember, I'm not doing any math here. I'm just assigning all of the values in L1 into this new resulting answer that I've called ANS, short for answer. The last time we do that through, we get a 3. There's nothing wrong with that. In order to get all of the values, we need a way to get back to the front of the singly linked list. And so to do that, we need to reference root and not answer. If we call recursive print on root, we're going to almost have the right answer. However, when we call this empty function list node, it initialized the first variable as 0, and that really isn't part of our answer. So we would need to call something like root.next. So we would skip over that first dummy variable that really doesn't matter to us. And lo and behold, if we do that, we get the exact same output as L1. Okay, I think that is going to give us all of the tools that we're going to need in order to solve this problem very, very efficiently. I'll see you guys in a minute.